in first quarter. And also CAPM exam, those are actually want to give exam on CAPM. That is actually not changing. That will also based on 6th edition until the 7th edition is published. Okay. All right. So let me share my screen first. Share screen. And okay. Share. So am I audible and visible? Can you see my screen? I am sharing with you a PDF file. Can you see this?
Yes, yes.
Okay, all right. So in the last class, we actually practiced how to find out. We have seen how to find out critical path of network diagram. But that is an easy technique you can use to find out the critical path. But to find out the best way finding out the critical path in a network diagram is forward pass and backward pass. And also to find out float of each activity, the best way is to using forward pass and backward pass. All right. So this is a network diagram, very simple network diagram. Only these are the 3 nodes. 3 nodes means 3 tasks actually. Huh? So first task is A, B, C, and D. So this is the start of the network diagram, and this is the finish of the network diagram. All right. So this is a start, and this is finish. Now we want to calculate the critical part of this network. So if you can remember the earlier last class, we can actually easily find out the network path, right? By adding the first you have to identify how many paths are here. So how many paths are here? There are only 2 paths, right? A, B, and A, B, D is one path, right? And another path is this one, right? That is actually A, C, D. Okay. So if we add all the duration, this actually the duration. This is the activity name in the middle, activity name, and this actually at the top middle, this is actually the duration of the task. So 5 plus 5 plus 15, that is actually 30. So 30 days is the length of the first path, this path. And the length of the second path, if we add A, C, and D, we are getting 5, 10, 15, and 15. I did wrong most probably, na?
Sir, upperta 25 hobe, nicheta
25, right? Upperta 25. 5, 5, 10, and 15, 25. And the below one is 30. Below one is 30. So this is 25, and this is, let me erase this. So from the earlier discussion in the last class, we can easily find out that this one is actually the critical path, right? The longest path is the critical path. So this is one way to find out the critical path. But the best way, let's discuss, the best way is finding out the 4 extra variables. We have to understand 4 variables of each task. This blank space, this actually every task we can present as by 4 variables. One is earliest start. Earliest when this task A we can start. And early finish. Early finish means earliest when a task can be finished. This date we can find out from here. And this field is actually late start. And this field is known as late finish. Late start means when actually we can, at the latest, when we can actually start the task. And at the latest, when we can finish the task. যদি বাংলায় বলি যে মানে আমরা খুব দেরি করতে থাকি যদি, তাহলে কত দেরিতে শুরু করলেও লেট স্টার্ট করলেও এই কাজে কোনো সমস্যা হবে না, এবং কত দেরিতে এটা ফিনিশ করলেও এই কাজের কোনো প্রবলেম হবে না। So that is known as actually late start and late finish. Early start হচ্ছে কত দ্রুত আমরা কাজটা শুরু করতে পারি, and early finish হচ্ছে কত দ্রুত মানে বেস্ট কোন পসিবল সময় আমরা শেষ করতে পারি, এটা বেস্ট পসিবল আর্লিয়েস্ট কখন আমরা শেষ করতে পারি। So these are the 4 variables for each task. So there is a formula. There are actually 2-3 formulas you have to understand when you will use forward pass and backward pass. Forward pass and backward pass. So one thing is, first we have to identify early start and early finish for each activity. For each activity, you have to find out early start and early finish for each activity. This is the first rule. Okay. So our duration is given. So if we want to find out the earliest start for this task, when can we start this task earliest? This is the start. That means this is actually first day, one day. So there is no dependency. So we can start this task on first day. So the earliest start for this task is day 1. So I am writing early start is 1. Then how do we find out early finish? So for early finish, there is a formula. Early finish equal to early start plus duration, DUR minus 1. This is the formula to calculate early finish of a task. So if you want to identify early finish of this task, then what will happen? We have to, what will happen? 1 plus duration equal to 5. So we are getting 6 minus 1. That means 5. So on 5th day, formula কি? This is formula.
এখানে অনেকে তো জিরো দিয়েও করে না, জিরো দিয়েও তো হয় মনে হয় না, if I consider early start as 0.
Yes. 0 দিয়ে you can do. Same result will come. Critical path will be the same.
Okay.
But early start and early finish day will be different then, but result will be same. Okay. So Shahid, you are asking why minus 1. That is actually coming a formula, because if you see here, we are starting the work on first day, so it will take 5th day, 5 days. So ultimately 1, 2, 3, 4, 5. Just if I calculate on my finger, 1, 2, 3, 4, 5. So on 5th day, the work is finished. So that's why actually we are adding duration, but we are subtracting by 1. But this is one way of doing this. There is another way actually, but in PMBOK that way is not mentioned, but you can use in that way. In that case, actually there is no minus there. Just early start is 0 and the early finish date is 0 plus 5 equal to 5th. 0 means first day and 5th means 5th day. Okay. So we are not going there because that is another way of doing this, but we are actually trying to follow the PMBOK way. So that's why actually we are subtracting, and when we will actually do the backward pass, then we will actually add plus 1. We will use plus 1. That way actually it will be what I say, equalized. We are doing here minus. When we will come into backward pass, then we will again plus. So all right, so 1 and 5 early finished. Now earliest when we can start this task B. Earliest when can we start? Not 5th day, because 5th day we are working 8 tasks. So earliest we can start this task is on 6th day. All right. Similarly, this task also we can start on the 6th day, because there is dependency related to this one. If this finish, then we can start this one. All these are actually finished to start relationship, right? So that means A is done. At the same time, we can start B, and same time we can start C. So early start for B and C is 6th day. Then if you use this formula to find out this finish date, 6 plus 5 is 11 minus 1. That means on 10th day we can finish this task. Now come here. here 6 plus 10 is equal to 16 minus 1. That means on 15th day we can finish this task. So this way we have found out these three tasks: early start and early finish. Now we need to calculate the early start of this task. All right. So what if we come through this way? That means on 11th day we can start this task. 11th day, right? But this relationship means what? That means these two tasks need to finish up before starting this task. But that means this task is finished on day 10th. That's why we are saying that on 11th we can start this task. But no way, because this task starts depends upon also this finish of this task, right? So this task is going to finish on 15th. That means another early start date is coming from here is 16th. So what shall we take? We take the highest one, right? Because these two tasks need to finish to start this task. We cannot take 11. We have to wait for this task to finish. So that's why this will be the highest one, the 16th. We will take the 16th one. All right. So 16 plus 15 equal to 31 minus 1 equal to 30. That means this is the earliest finish date of the last task. So you see, following the forward pass and using this formula, we have calculated early start and early finish of all the tasks. Now we'll use the backward pass, BP, backward pass. In backward pass, what we'll do, we actually will find out the late start, late finish, and late start of all activities. And we have to start from the last task. In forward pass, we have started from the first task. But for backward pass, we have to start with the last task or last node. And we are seeing here the last earliest finish we can finish the task is 30. So late finish will also be 30. Because from forward pass we have got that the last task finish date is 13. So last nodes or last task finish date, last finish will be also 30. All right. So we cannot make delay because we have already got from forward pass that this task earliest we can finish on 30. So latest also we have to finish by 30. Now for here we actually calculate early finish. Now we have to calculate, as we are coming up in opposite direction, we have to calculate what? We have to calculate late start. So what is the formula of late start? Late start is late finish minus duration. The opposite of this formula, plus 1. This will be the formula for finding out the late start. So for this task, if you want to find out the late start, what we need to do, 30 minus duration is 15. So 15, we are getting 15 plus 1. That means this will be 16. So for this task, late start will be 16. Okay. Now we have to calculate late finish of this task and late finish of this task. So when we can let us finish this task, this is 16. That means on 15th we have to finish this task. Latest we have to finish the task on 15th, so that on 16th we can start later start happens. And for this task also what will happen, 16th, that means we can start late finish for this task will be 15. And that's just earlier date. In this case we actually take the next date, but when we are coming in the backward pass, we'll take the earliest date. So 16, that means it will be 15. So now we want to calculate this one, late finish, late start for B task. So 15 minus 5 equal to 10 plus 1. I am using this formula, plus 1. This is actually 11. All right. In this case, what will happen? 15 minus 10 equal to 5 plus 1, that will be 6. All right. Now we need to find out this task let start and let finish. But how can we find out this? If you see, if you come from this path, then let finish will be on 5th day. All right. But if we come from this path, that will be 10th day. So in this case, we have to take the lowest one, lowest value. In this case, we take the highest value, but when we use the backward pass, we have to take the lowest value. So we cannot take 10th day, we have to take day 5th. All right. So 5 minus 5 equal to 0 plus 1 equal to 1. So now see, we have found out all the early start, early finish, late start, late finish of all the activities. So when this is done, now you have to use another formula to find out the float of every node or every task. That formula is float equal to early late start minus early start. There is actually variation of this formula. Float equal to minus of this one minus this one, or this one, late finish minus early finish. So same formula, and you will get the same value, but two variations actually. So float we can find out by subtracting late start minus early start, or subtracting late finish minus early finish. So if we want to calculate float for all this gap, this actually for finding out the float. So if we use this formula for every node, what will happen? Early start minus late start minus early start. What will happen? 1 minus 1, 0. Or 5 minus 5, 0. Right? For this task, can anyone say what will be the float for this task?
11
5.
minus 6, 5.
11 minus 6 equal to 5, or 15 minus 10 equal to 5. Same result will come. And for this, 0, right? 30 minus 30, 0, or 16 minus 16, 0. For this task, 15 minus 15, 0, 6 minus 6, 0. Anyone you can use. All
So
right?
6 minus 6, 0, and 15 minus 15, 0.
0, right. So
Reza bhai,
see,
what is slack?
slack and float is the same thing.
Same meaning. Okay.
Same meaning. So earlier actually people used to use slack word frequently, but nowadays float is used mostly.
Okay. Thank you.
So, but in the exam, you can see two terms, float and slack, two terms you can see in the exam. All right. So if you see these tasks A, C, and D, these tasks are having float 0. So earlier when you have used in the last class, when you have add everything, then actually we have assumed that in critical path, every task float will be 0. But here mathematically, we have found out that these are the 3 tasks, and this is the path in which path every task is critical, because float is 0. That means you cannot delay any task of this path by 1 day. If you delay by 1 day, the project schedule will be shifted. So that's why this path is critical path. All right. And this path is not critical, right? The above path A, B, D is not critical because one task B is having 5 days of float. All right. So this way you can find the critical path, and also you can find float for every task in the network diagram. All right. So I am saving this for your reference. I will share after the class. So if you have any question, you can ask me.
I have a question here, like free float, total float, project float, and negative float.
Hmm.
Can you elaborate on this, looking into this diagram?
Okay, so always remember the way we have find out the float, this is actually total float.
Okay.
So there is no formula to find out free float. Free float actually, this is actually total, it is related to total network diagram. This float, total float is related to total path and also related to project finish date. But when we are talking about, let me share my white screen. Okay, so can you see my white screen?
Yes. I can see.
All right. So when you are talking about free float, so total float, I think you have understood. It is related to project finish date. Delaying one task, if it doesn't delay the finish date of the project, then that is actually float for that task.
Okay.
And it is actually related to total network path. But what is free float? Free float is related to successor. Say A is one task, B is another task, and C is another task. And this means what? To start C, you have to finish A and also you have to finish B. But if it is like this, A task takes 5 days and B task takes 10 days. That means if we want to start this task, we have to start this task on which date? 11th date, right?
Yeah.
So what happens? For this task, there is no free float, but for a task, there is free float for 5 days. If we start this task after 5 days, it will not impact on C. It is in its immediate successor activity. Early start of its immediate successor activities, it has no impact if I delay this task by 5 days. So that is actually snippet of a network diagram. And from this snippet, we can say for this relationship, A has the free float of 5 days, but B is not having any free float. Free float for B is 0. But for A, it is 5 days. So it is actually just snippet of the network diagram. So if I delay any task and it has no impact on the immediate early start of any task, then that duration is known as free float.
Rajabhai, is it only applicable for the forward pass or it can be deduced in the backward pass as well?
Backward pass. I did not think about like that. I have not thought earlier about that.
Okay.
So I have no answer at this moment.
I came through a barrage of problems while doing some online simulation. So I just curious to know. That is my question. Another one is like for the earlier diagram, you are talking about total float. What could be the total float of that particular diagram? I mean, the diagram which I have just finished.
That total float for not the total diagram. Total float for that path, ABD path.
ABD path. Yes.
For ABD path, the total float is 5 days.
It's 5 days.
5 days.
For the critical path, we don't have any float.
No float.
No
float, nothing. It is always 0. 0 or negative. That is very important to know because that can be 0 or can also be negative. Critical task can be also negative float. All right, not only 0. That you should remember because in PMBOK that is mentioned specifically. So in the exam, you can get some options. So critical task is always 0. That is true, but also negative also can be critical path.
What is the significance of having negative, float? Is there any
negative float means, significant means there is already some problem occurred in the network diagram. You are already behind the schedule. Okay. All right, you are already behind the schedule. That I shown you earlier, the negative float. If you see any negative float, if you use any software, then it will automatically show negative float, minus something it will show. So if you see negative float, that means there is on that nodes or on that task, there is some problem. Problem is you have already behind the schedule. So you have to rectify that schedule. Otherwise, you will it will actually impact total project schedule in the future. So you have to find out those negative floats and you have to solve those negative floats. All right.
Okay.
And project float is easy. You will get a question about project float. So any doubt about that project float? So project float is actually if customers say that you have to deliver by 13th of December, but if you see you can finish the task by 15th December, that means you have another 15 days in your hand, right? Within that, if you deliver the project, nothing wrong will happen. Customer will not say anything about that. So you have 15 days project float. That's the total project you can delay by another 15 days, but still you will able to manage, able to achieve the customer's specified date. So that is actually project float. So
this can only happen when I am on top of schedule.
Yes, right. You are on top of schedule, and you are actually well in a good shape.
Yeah, well in line with the planned activities.
Yes, right. Okay, so let me share my presentation slides. So this one. So we actually shown this in the PDF file. We have practiced this one actually, right? So you see this solution is here, and this is actually the result: early start, early finish, duration, total float, last start, late start, and late finish. And this black one, this bold black one is the critical path. This is critical path. In the softwares, always it shows like actually red. But here in PMBOK actually no color is used. So critical path is shown as bold. And this one is actually non-critical path. And this B, right? B is having 5 days of float. For other tasks, there is no float. All right. Okay, so this formula we used, right? For forward pass and backward pass. And there is a big math here also. You can try this, and the solution is also given here in these slides, and this red excludes the critical path. So you can practice this. All right. And in the exam, it is not true that always you will get this type of network diagram. What can happen, you can get one node in the exam like this. See, like this node is given in the exam. You have to find out the float of this node, duration of this node, and early finish of this node. So can we try for this, try to solve this? Can we try to solve this? So what will be the, let's find out the early finish, right? Early finish of the task. How will find out this? We have to find out float, we have to find out duration and early finish. So we have what we are having in our hand. We are getting this is what late start, and this is actually late finish, right? So how can we find out the float? We have given late start and we have given early start. So if we can use this formula, right? So what will be the float for this task?
16.
Right, 16. So float will be 16. So in the exam, questions can be like this. Only one node and you have to find out the float. Other things are given. All right, or this can happen. 3 variable, you have to find out the 3 answers. In the exam, not 3 answers will come, but I am actually showing here. So then what will be the early finish for this task?
23.
Hmm? So how can we find out that?
Late finish minus early finish.
Hmm? So before that, actually, we need to find out the duration, right?
Exactly.
So how can we calculate the duration? What will be the duration of the task? Can anyone say what will be the duration for this task?
2.
37, 39, right?
Yes.
So if you, for this case, if you use the finger, so 37, 38, and 39. So it will take actually 3 days,
3 days. Yeah. There is a
right?
1.
Huh? So this is actually inclusive, huh? 37, 38, 39. So it will take 3 days. So now if you want to find out the early finish, what will happen? So 21 plus 3, that is actually 24 minus 1. So that will be 23. So this is the early finish for this task. So if you calculate now 21, 22, 23. So it is actually taking 3 days. All right. So this way you can find questions in the exam. Not the full network diagram, maybe just a snippet of the network diagram or just a single node. So if you can remember these two formula, so you can easily make the answer correct. All right.
So Rajabhai, you have not put any calculation over here. The calculation we have just seen here is not written in the printout. I have seen your earlier videos and I have also did the same thing. But right now I came to know this is how we can get this the result.
Okay.
Very tricky one. When you are a pressure cooker situation, it is going to be a tricky one. The most trickiest one is the +1 and -1.
All right. So that's why actually the I think finger calculation is good. 21, 22, 23. Then you will easily understand that it will need 3 days. The duration will be 3 days. Otherwise, what will happen? You will say this is actually 2 days. That Sadman was saying. So this type of small questions you will find at the exam. Very easy but tricky.
Can you say again, Raja bhai, মানে এই জায়গাটায় 21 plus 2, এই 2টা কোথা থেকে আসলো? Still not clear to me.
No, not 2. This is actually 3.
3. 2 plus 1.
20. I am saying like this. Let me write down here. 37 day, 38 day, and 39 day. All inclusive actually.
All inclusive.
So that's why 3 days. All right. Or if you use the formula, this formula, let me go back. This formula, early finish. How do you calculate early finish? Early start plus duration minus 1. So if we use this formula in the next, here. So we have got duration 3 days. So what will happen? How do we calculate this? 21 plus 3 equal to 24 minus 1 equal to 23. All right. Or we can add in the finger 21, 22, and 23. So 23 will be the early finish date.
Yeah. Thank you.
All right. So now let's discuss about some other tools of developed schedule. That is actually resource optimization. So why resource optimization? Resource optimization means, so we need resource to finish a task, but resources are not what I say, exhaustive, or the resource we need will get all the resource. It is not possible. Every time you will get or see a scarce of resource. Or for example, an expert, there is a software architect or an architect, engineering or construction project architect. Say in the company only architect is there. There are 5-6 projects that's running. So then what you need to do? You need to level the architect so that he can give time, adequate time for all the projects, because we are having only one architect. So that's where actually resource leveling is coming. the idea of resource leveling. And also some resources will be on leave, some resources will be sick. So how do you actually level your resource so that your activity doesn't hamper? The absence of resource doesn't geoprioritize your task, your activity, your project. So that's why you have to do resource leveling. So resource leveling, if you use any software, every software is having a resource leveling tool. So resource leveling means what? So if there is any crisis related to risk, resource, so what resource leveling try to do? He actually try to find out slack or float or next available time of that resource and try to shift the task with the time of that resource, available time of the resource. That's why if you do the resource leveling, what happens generally, it actually increase the project schedule, because it try to find out when the resource is scheduled, a resource is free. All right. So if there is no free slack or float, then what happens? It actually try to shift the project schedule. The schedule will be increased, extended, expand. So that's why management actually not actually always agree with the resource leveling thing. They actually sometimes try to push resource smoothing. What is resource smoothing? Resource smoothing is resource is same. You cannot increase resource. You cannot increase schedule. What you need to do, you have to motivate people, so that they work hard. Not they work hard. They work smartly, and they are more productive in their time. So if you are in a productive mode, just today I was listening lecture, Harvard medical review. So they are saying that if you have a happy mind and if you are having an unhappy mind, so say some days we are having a very happy mind. So on that day, actually people are 31% more productive than on those days when he is actually unhappy, having unhappy mind. All right. So if you having happy mind, you will be on that day 31% motivated, productive. So that is actually great statistics. So that's why actually we need to make or keep our employees happy always. So they will be more productive. So if you want to keep always in push, in pressure, they will lose their productivity. So resource smoothing is somehow you have to increase the productivity. You cannot extend time. You cannot increase resource. That's why you have to somehow smooth or complete your task or complete your project. So you cannot increase time. You cannot increase resource. So that is the difference between resource smoothing and resource leveling. So resource leveling will increase the schedule, generally increase the schedule, but in resource smoothing, schedule will not be increased. Within the time the work will be done, how will do? You have to motivate people, you have to make people more productive. That is known as resource smoothing. All right. So these two terms, you will get one question from these two terms.
এই রিসোর্স লেভেলিং এবং রিসোর্স স্মুথিং দুটাতে ওই আমাদের যে ক্র্যাশিং এবং যে টেকনিক গুলো আছে ওগুলো কি এটার সাথে অ্যানালগাস?
একদম ডাইরেক্টলি অ্যানালগাস না আর কি, ডাইরেক্টলি না। সো বাট ফ্লোটের সাথে খুবই রিলেটেড। স্মুথিং এ অ্যাকচুয়ালি ফ্লোট বের করে করে যখন ফ্রি আছে রিসোর্স বা ফ্লোট আছে ওই জায়গায় রিসোর্সকে ইনভলভ করে করে কাজটা শেষ করা হয় আর কি, যাতে ডিউরেশনটা বেড়ে না যায়। কিন্তু রিসোর্স লেভেলিং এ আসলে ধরাই হয় যে ডিউরেশনটা ধরাই হয়, মানে রিসোর্স লেভেলিং করতে গেলে সফটওয়্যার ইউজ করছেন কিনা জানি না, মানে সফটওয়্যার ইউজ করলে দেখা যায় যে অটোমেটিকলি সে আসলে শিডিউলটা এক্সটেন্ড করে ফেলে, বিকজ whenever a resource is attached with a task, so any software thinks that resource is mandatory for the task. So when the resource will be available, that task generally shift with that free time of that resource. That's why actually time increased.
ওকে, Suppose I am doing an excavation work for roads and highways. In that case, I have got the excavation materials. So with the help of this project calendar or resource calendar, I would like to smoothen my work with optimum utilization of resources.
Mhm.
So এইটার মধ্যে তখন কি resource smoothing example will come into play, right?
Right. But you have to always try to find out the use resource smoothing, because management will not give you resource, extra time. So that's why you have to focus on, if you can find out any way by smoothing your resources, if you can find out any way to finish the project on time. So that will be your first target. But if you don't, you are not having any way, then you can use resource leveling. But then actually you have to take approval from your management.
So
So
resource leveling is always expensive then.
yes, always expensive. But this is actually expensive in one way, when actually resource constant is there. But resource leveling is other ways. You have to understand that there is only one architect. So you have to label the resources, and resource leveling, there is actually quite a different type of perspective. One perspective is, let me show you here. In construction project, say this is the time of the project, and this is actually resource requirements. So say for first week you need 10 laborers,
Yeah.
and next week you need 50 laborers.
Yeah.
Then again you need say 20 laborers, and in the next week you need just 5 laborers. Again, next week you need say 100 laborers. So if you make or plan your schedule, plan your project like this, then actually you will fall into trouble, because you cannot arrange laborers. So what you have to plan, you have to smoothing here. Here you have to use resource leveling. What you have to do, you have to plan like this. Say for 5 weeks, my resource will be like this. Right? There should be leveling, so that I can easily find out labors. Otherwise, if you use this, you will fall in trouble, because always you will not get the correct or appropriate labors for your task, for your job. So this is also another perspective of resource leveling.
Okay.
All right.
Yeah.
So there are actually 3-4 perspectives. If you read that portion of PMBOK, you will understand. This is one perspective.
Yeah.
So you have to plan like this, so that the sourcing of resource should leveled. Otherwise, you will not find out the resource when it will require. Okay, here this is actually one figure that is attached, first introduced in this PMBOK 6th edition. So here, if you see activities before resource leveling, this figure actually will make us understand how resource leveling is actually increase the schedule. So first, in the first part, if you see activity A and activity B, 2 are running in parallel, and 2 takes actually 1 day. 1 day means 8 hours. But for first task, 2 people need to work together. One is Tom, another is Sue. And for activity to complete, it needs 8 hours, and Sue is the person who need to work here. And for activity C, only Tom is required, and he will work full day. Full day means 8 hours. So if this is actually a chart, schedule. So what happens if we add this? Tom is for 8 hours day 1, but Sue is 16 days. That means it is not possible for a man to work double, 16 hours a day. So here we are seeing Sue is 16 hours, and then second day, what is happening? Tom is only involved and 8 hours. So there is no problem with task C. But problem is Sue is overloaded here by 8 hours a single day. So though schedule is showing we can finish this task within 2 days, but as Sue is required and Sue is overloaded, it is not actually possible. Theoretically, it is okay, but practically it is not possible. So then we will apply resource leveling. see the next figure. So what we are doing, as for activity A, Tom and Sue required for 8 hours. So what we are doing, in day 1, Tom is 8 hours, Sue is 8 hours. But activity B, we push that activity on the day 2 when Sue is free, right? And Sue now is giving 8 hours. And ultimately, as A and B, C is depending upon what? Both these tasks need to complete. So C is actually shifted to day 3. So practically what happens when you are doing resource leveling, the schedule is increased by 1 day. So this is the actually general practice if you use resource leveling. It actually try to push the schedule. So any confusion with this figure? Very nice figure to understand what is this leveling.
জি রেজা ভাই, একটাই ইম্প্যাক্ট হচ্ছে with the date, no impact with the resources.
No, because with resource leveling, we are actually trying to remove the impact on resource.
On resource.
Because you cannot ask people to work 16 hours. It is not possible. And if you, this way, if you do push people, then actually you will not get people in your project. So one of the performance measurement for project success is the team that work in your project, they are also in the next project, they are also interested to work with you. There is another performance measure for projects. If nobody wants to work with you, that means there was some problem, people problem that happened in the earlier project.
But is it going to have impact on my critical path then? If I start.
Yes. If it is if the task is critical path, then actually project schedule will be changed. If it is in the critical path. All right. So it can push the critical path and also push the project schedule. So if it happens that it is changing the critical path, then you need to talk with your stakeholders, with your sponsors. Then actually we will discuss crashing and fast tracking, where actually we can.
Yes.
Oh, someone is calling.
Hello.
Yes, hello. Can you hear me?
জি রেজা ভাই শুনতে পাচ্ছি।
There is a phone call from my university teacher, my department professor. So we are trying to do some work together. So that's why he's.
Okay. Regarding project management or something?
Project management. He is by actually university thesis professor. So he actually first introduced project management in Dhaka University Computer Science Department. First, he introduced actually project management, and inspired by me actually. So for a couple of years, he is taking class in the master's project management. All right.
So you were in the background then.
In the background, nobody knows me, but.
So when your background is bright, then your picture is going to be brighter.
Right.
Thank you.
All right. So let me talk about an advanced scheduling technique that is actually modeling technique. So you don't need to understand how this modeling is happened. How do we need to do simulation? What is Monte Carlo analysis deeply or fully? You don't need to understand. Just you have to remember for scheduling, we can use modeling technique, and modeling technique actually by using what if scenario analysis. One is what if scenario analysis. What if scenario means what? Actually, for every task, we can actually find out if X is there, then what will happen of the duration of this task. If this happens, what will happen? If that happens, what will happen of the duration of the task? If one, for example, if one person is sick, then what will happen of the task? Can we complete within 5 days? So this what, and this is actually what if scenario analysis. Then what if one employee left the organization during the project, what will happen then? Then if the productivity, the whole team say they actually lose productivity or lose motivation, then what will happen? So this way, using lot of data, you can actually find out the optimum duration of a task. That is actually known as what if scenario analysis. And when we are using what if scenario analysis or simulation, the mostly used simulation technique is Monte Carlo analysis. So when we are talking about simulation and what if scenario analysis, then actually we have to take lot of sample data. So using that data, that probability, that data, we have to find out the probability of each task, and then we have to accumulate all the probabilities, all the probabilities, and we have to find out the simulation distribution. So from that, we can find out the probability of finishing the project within a certain time. So for example, using some simulation technique, for example, we have find out this is the distribution of our project. And what is actually, we can find out from this simulation. Let me explain here. So for example, we are saying this is the date 30th May 30th of May 2017, and this is 13th May 2017. So if you see, if management wants to finish the project by 13th of May, the probability is only 10%, 10% probability. You can finish by 13th May. But if you come here, see this point, at 28 May, the probability of finishing this task by 28 May is 90%. Okay, so if you use simulation, then actually you can say the probability of finishing the project in certain range. So if you want to get 90% surety that you will finish your project on 18th project, then you will have to say your management, then we can finish only by 28 May 17. But if you target to finish the task, finish the project by 13th May, then actually only 10% probability is there. And if you want to finish, your management want 100% surety, then actually you have to say that 16th of June is the day when we can say that 100% sure we can finish the project within that time. So that way, actually, if we use simulation, we can actually see the future. And we can see the probability of finishing a task within certain time or certain date. So that way, probability can help us. Okay. So sometimes actually in the PMP exam, you can see this picture. All right. And they can actually ask questions. If you want to get 90% probability, so which date will be the project, which date you will pick? So from here we can see 28 May is the date when we can assure that the project will shoot 90% assured that project will finish on 28 May.
Reservoir here, the fluctuation in bar chart, it shows the resource deployment to achieve the result, finishing the project.
This fluctuation.
Yes.
Not only resource, that can be different parameters you can use.
Okay.
It is actually not mentioned. Most probably here it is mentioned different activity assumptions, usually using probability distribution constructed from the 3-point estimate. It actually use 3-point estimate for each activity. Optimistic, most likely, and pessimistic for all activities for a project. Okay, So from that 3 parameters for every task, this actually draw. Same picture we will see in the cost chapter. Then actually we can also say the probability of finishing a project within certain budget.
Okay.
So these texts we can use. These are advanced feature. But if you want to understand or if you want to learn and apply in your project, then you will get a lot of videos in YouTube. How to use especially Monte Carlo analysis or simulation technique in scheduling or budgeting a project.
Name itself is quite abstract to me when I
Which
first
name?
encountered name itself, Monte Carlo analysis.
Right.
Probably
So,
the background behind is like it's introduced in Monte Carlo or someone Monte Carlo named Monte Carlo. Monte Carlo.
Monte Carlo,
I don't
can
know.
anyone say what is Monte Carlo? And why the name is
Probably
Monte Carlo? What is Monte Carlo? Can anyone say? What is Monte Carlo? Is it a name of person or is it a name of anything? What? So Monte Carlo is a small country in Europe.
Country name.
Country name. Very small, most probably 2 kilometers or something. But this is actually famous for casino. People
casino.
actually, yes, travel there for playing casino. Famous for casino. So as we are talking about simulation, casino, what happens in casino?
Yeah.
That is actually one time we are actually throwing the, what is it? Chakka যেটাকে বলি আমরা।
Dice.
Die.
Yeah.
So die যে আমরা ছুড়ি, তো ক্যাসিনোতে এইভাবে খেলা হয়, die ছুড়ে, তাই না? So from there actually that simulation name is taken actually from Monte Carlo and its name is taken from there, from casino. Okay, so we are actually in the develop schedule process and we can use final leads and lags because we are now finalizing our task, and if we can use project management software, and also we can use schedule compression. So let me finish this chapter today, then we will actually finish. So compression, the idea of compression we need to understand. So when we make a schedule and we actually present to our management, every time management will say what? Will management approve your schedule? Always they will say we have actually schedule constraint, we have a budget constraint, you have to finish the project. You have shown that we will take 6 months. They will say you have to finish the project by 4 months. That always happens. You cannot make your sponsor happy. So they always try to push you to finish the task as early as possible. So that's where actually schedule compression come into play. That means you have to squeeze or compress your schedule. So you have made the schedule 6 months. Now management is asking to finish the project within 4 months. So how do you do that? How can you reduce 2 months? So there is 2 techniques for schedule compression or schedule reducing. So one is crashing. Crashing means increasing more resource. So for one task, if you plan that you will use 2 resources, then it will take say 4 days. But if you double the resource, say if you involve 4 people, then this may happen that 4 days task can come into 2 days, can be finished by 2 days. So that is actually known as crashing. That means you are involving more resource to finish the task early, finish the task fast. So when you're actually increasing resource, what is happening? It is also increasing cost. So if management approve this, then that is okay. Management is mainly focused on schedule. So this cost if increase and they agree, then you can use crashing technique to compress your schedule. All right. Then let's talk about fast tracking. Another technique is fast tracking. So fast tracking is what? Fast tracking is actually management will not always approve increase of resource or increase of cost. So the best technique is fast tracking. What is fast tracking? Fast tracking is doing work parallelly. Earlier we have planned that after finishing one task, we'll finish another task. But now we are, as management is pressurizing us, we are thinking that we have to the work we have planned serially, sequentially, now we will do parallelly. For example, if you see here, so we have earlier planned that these two tasks, these three tasks we will do serially: complete drywall, paint interior, install carpet. So it will take 15 days, 8 days, 8 days. That means it will take 31 days, right? But now we have to compress. So what we planned, this task after 15 days, but these two tasks earlier we planned serially to do it serially. Now we are doing it parallelly, right? So when we are doing parallelly, then what happens? 15,
23 days.
this 23 days, right? So that's why we can actually reduce 8 days. So this technique is known as fast tracking. আমরা ডাচ বাংলা ব্যাংকের ফাস্ট ট্র্যাক দেখছি না, ডাচ বাংলা ব্যাংক ফাস্ট ট্র্যাক. So fast track mean is actually overlapping or doing in parallel. Why does Bangla Bank ATM booth is known as fast track? Can anyone say why it is fast track? Just for understanding.
একই সময় টাকা তুলে এবং টাকা জমা দেওয়া যায় একই জায়গায়
জমা দেওয়া যায় এবং you can do some banking also.
Yeah, exactly.
There is a person who also help you banking. But in other ATM booths, you will see only one booth is there and you are actually in queue. So one person is inside, you have to stand outside of the booth on the road or on the footpath in queue. But if you go in DBBL fast tracking, there are actually 3, 4, 5, 6 or even 8, 10 ATM booths. So you will hardly see there is any queue. So you can, people are working or taking the service parallelly. So that is actually fast tracking. Just this example is for to remember what is fast tracking is. Fast tracking is doing parallelly or overlapping. But what will happen if you do overlap? It will actually, task will be risky. So when we are doing these two tasks at a time, then what happens? Both tasks will be in risk, right? And individual activities taking longer time because both tasks are now running together. So what will happen? Maybe within 8 days you cannot finish. Maybe it will take 10 days. It will take maybe 9 days. All right, it happens, right? When we do work parallelly. So these are the impact. So these are the figures, actually an example we used earlier when PMBOK was not using any or given any figure. But from 6th edition, there is a interesting figure given in PMBOK. So if you see this figure, you can easily understand what is fast tracking and what is crashing. And from this diagram and this concept, crashing and fast tracking, you will get at least 1 or 2 questions. All right. So if you see that in normal case, one person is working and it is taking 5 days. And this second task, it is taking another 5 days. One person is involved and here another 5 days. So total how many days? 15 days, right? Okay. So when you are doing fast tracking means what? Doing some part of the task parallelly or overlapping. So what we are doing? We are doing completing task parallelly. Here also we are doing parallelly. So it is taking 11 days. We have not increased any resource. We are doing the work parallelly. So what happens? What is the impact? Risk is high. Okay. So that's why you know that when you are as a person trying to do a lot of work together, then actually everything will be slowed down. So that's why people are now saying that you have to focus one task at a time. First, identify which task you want to do, then prioritize what is important, then task by task you have to finish. Otherwise, if you try to do everything, actually nothing will be finished, and quality of your task will be degraded. So that's why people are now saying focus one task at a time. So high risk. Now, see the crashing figure. So we are involving 2 people. So we are increasing resource. What happens then? Maybe the 5 days work now is finished within 3 days. And 2 people are here. So 5 days work can be finished by 4 days. And again, this will take 3 days. as we have increased our resource. So when we are increasing our resource, that means actually cost is increasing, right? Cost is dollar value is increasing, and it is finished by 10 days. So this way, fast tracking can help us, or crashing can help us to compress our schedule. But please remember, fast tracking associate high risk, and crashing actually increase the cost of the project. So which one you have to use, you will use, that you have to decide in your based on your situation and based on your sponsors or stakeholders approval. Yes.
If we consider fast tracking and crashing, would you be using only the resource as a human resource, or it could be materials and other resources?
Yes, material, other resources, other equipments.
Other equipments. In that case, if I take the example of DBBL fast track ATM machine, if I the reason behind having fast track is like they have line up multiple machines with different service offerings. So in that case, how the risk is going to be increased if I consider that example as a fast tracking, considering the machine only? Instead of one machine, they do have multiple machines providing the facilities to the.
No, there is no risk there. That is actually I have given example for just understand the parallel thing.
Okay, and yes, I can easily understand the example you have given here, like the human resource thing. But if I consider the machine, ATM machine, then the only risk is if it is gutted or some disruption happen, then only machine is going out of order, may go out of order. But it is more applicable to the human resource than probably machines.
As human resource, and also especially human resource actually.
Yeah.
All right. Okay, so last thing about develop schedule, that is actually we talked that this figure is actually add in the PMBOK edition, Agile release plan. In Agile, how do we make schedule, right? So very interesting figure. We have discussed the concept of Agile, and we have already discussed that in Agile, we actually don't do the whole planning at a time. We actually, the planning is also iterative, the scheduling also iterative, right? So how actually we do in Agile, the scheduling part we do. So see, Agile release planning. So what we do, we actually divide the product. So we have to make a product. So we actually divide the product release, final product release into, say for a product we have thought that we will have to have 3 release. In one release, we will provide some part of that part is known as MVP, minimal viable product. So we'll deliver some part of the product, and in release 2 another part, and in release 3 we'll finish the product. So after planning the release, all right, we then actually now we are breaking down that release into iterations. So for this example, now we are doing release planning. So first we are doing the product roadmap, and in that roadmap we have identified that to complete the product we will need 3 release. All right. Now we are dividing one release by one release first. So that first release, now we are doing release planning. In that release planning, we are dividing and finding out that we will need 0 to n number of iterations to complete this release. All right. Now, after identifying this release planning, now we are again breaking down that iteration into iteration planning and a smaller component. So in iteration 1, we are planning that we will deliver feature 1, feature A, feature B, feature C, and feature D. All right. So now we are actually within a iteration planning, and as we mentioned, iteration plan maximum will be 2 weeks, as minimum 1 week to 4 weeks or 30 days. So within 30 days, we plan that we will deliver A feature, B, C, and D feature. All right. then we are actually breaking that feature into user stories, right? User stories. And for each user story, say for example, for feature A, we have to deliver 2 user story. For B, 1 user story, for C, 1, and for D, 1 user story. So now what we are doing, see, still we are not having any duration or hour calculation. Now when we are doing the story, again, now we are breaking user story into tasks, right? So to deliver this user story, we need to do these 4 tasks, A, B, C, D. Okay. And for task A, we need 5 hours, task B, 8 hours, task C, 6 hours, and task D is actually 12 hours. So if we can involve our team and they actually use their 5 hours, 8 hours, total hours, then actually this feature once user story 1 will be completed. When this is done, then actually we'll again divide this user story into tasks and we'll find out the duration of the task. So this way actually agile scheduling is done, right? So it starts with release planning, then iteration planning, then feature level, user story level, and then task. So there is similarity actually. In PMBOK, we are actually breaking the project. Can you remember breaking the project into what? WBS, right? And WBS major components we are breaking down to smaller WBS components, right? Smaller components. Then we are breaking that component into work package. See, these features are, or these user stories are work packages. And then these work packages we actually broken down into different activities or tasks. Activities or task 1, 2, 3. So similar thing actually happening in Agile also, but the names are different. And we are doing this iteratively and incrementally, not at the beginning. Once one iteration is coming, then we actually are taking some feature from the product backlogs and then breaking that feature into user stories. And again, we are breaking that user stories into tasks. And for each task, how much time we need. That way, we are finding out the schedule for Agile projects. Okay, so you may get 1 or 2 questions from this figure. All right. So if you have any question, yeah.
Product backlog is equivalent to WBS or work packages?
Equivalent to requirement documentation.
Product backlog equal to requirement documentation.
Requirement documentation. All the requirements will be in requirement document in PMBOK, predictive way, or a scope of statement. In Agile, it will be in product backlog or only backlog. Sometimes it is backlog, or some people it is in Scrum. It is known as product backlog.
WBS এর ইয়েটা কি হবে, equivalent to কি হবে in Agile ইয়েতে?
Agile this actually this feature.
জি.
Feature is WBS. User story is the work package, and within this work package, these are the tasks.
জি.
Okay. All right. So actually there are similarity, right? So there are actually terms. You have to understand these terms. So product feature.
Yeah, I am trying to, recalibrate the thing. ওটাই দেয় আর কি ওরা পরীক্ষায়। জি।
Right. Okay. So. Okay. So what shall I do? It is already 9, no? Okay, I think I can finish within another 10-15 minutes. So let's finish, right? Let's finish. So finally, what is happening after doing all this network diagram, then using critical path, we are actually finding out the schedule baseline. What is schedule baseline? That is actually the approved copy by the management. All right. So if management approved, then that is known as schedule baseline. And another term is their project schedule. That means the project schedule, that is the baseline, that can be actually presented as bar charts, milestone charts, project schedule network diagrams. In different ways, we can actually present the schedule baseline. All right, so that is actually known as project schedule. And one figure is added in PMBOK. So if you see this, so this first one actually example of milestone schedule. Only milestone are showing. And the second one is the high level work packages. That schedule is given here. Summary schedule. Only work packages schedule. And lastly, it is actually detailed activity schedule. Detailed schedule. Where there is work package also. And within the work package, all the tasks are mentioned here also. And also milestone is there. So this generally, when we are using any software, say Microsoft Project or Primavera, you can easily produce these kinds of bar chart, milestone chart, and detailed project schedule from any software you use. So these are the representation or presentation of the project schedule or schedule baseline. So once the schedule is confirmed by the management, then what will happen? That will be your reference point. Following that schedule, you have to complete your task, complete your project. All right. Schedule data is the supporting data. Why each task having this much time or this many days, that they're supporting documents, supporting information in a to capture. That is known as schedule data. And project calendar. So when you are making the final schedule, you have to use project calendar. I mentioned about this. Project calendar means what are the holidays, what are the weekends, and what is the working time of our office for this project. So that is known as project calendar. So before using any software, first you have to actually define project calendar, then you have to give input on all the tasks and their duration and create relationships. And finally, you have to use critical path method to find out the project schedule. So these were the outputs main, and additional outputs are actually only the updates of planning documents and also update of the project documents. So this is our final process. So far what we have seen, if we come here, can you see my chart? This table? Can you see?
No, sir.
No.
হ্যাঁ টেবিল দেখতে পাচ্ছি না
Oh, right. So MI. Okay. ঠিক আছে. So can you see now?
yes
All right. So what we did, we actually finished all these processes, right? Define activities, sequence activities, estimate active duration, and develop schedule. Now, what will happen? In develop schedule, we are getting schedule baseline. Then following that schedule baseline, we'll execute the project. And now in monitoring and control, we have another task, another process in schedule knowledge area, that is control schedule. That means, what is the scope of this control schedule? That means we have to follow the baseline and ensure that baseline is controlled. We are within that baseline, we are performing and we are delivering within that baseline. That is one perspective. Another perspective is whether is there any gap between the schedule baseline and what we are executing. Is there any gap? And third one is there any change request related to schedule? Is there a need to compress our schedule, or any new lead and lag we need to apply, or is there any new task added so that our schedule need to change? So those changes we need to do in this control schedule process, by this control schedule process. So these are the scope of control schedule process. So let me again go to the slides. So control schedule. As a project manager, we have to control our schedule as per the scope baseline, schedule baseline. So in control schedule, what will be the main input? See main input, this project schedule. That means the approved project schedule, the schedule baseline, schedule data, resource calendar, project calendars. These are actually the main input because we are going to control our schedule. All right. And schedule baseline. So these are the main inputs for control schedule process. All right. So in this control schedule process, we will use different tools, and main tools are earned value analysis that I will discuss in the next chapter, cost chapter. I will discuss in the next day, cost chapter. I will not discuss here. Then iteration burn down chart. This is actually agile way of monitoring your project progress. That is actually iteration burn down chart. That I will explain because there is a figure related to this. Performance review. That means any technique you can use as per the schedule baseline, how your team is performing. Then trend analysis. What is the trend? Are we online, or it is actually it is performance is up, or performance is stable, or performance is going downward? So that actually using trend analysis you can find out that. And variance analysis. Is there any variance against or refer to your schedule baseline? Is there any variance? So that you need to find out, and always you have to control your schedule. If you see any variances happening, so you have to take proactive actions so that you can actually reduce that variance. And what if scenario analysis, that actually we have seen in the develop schedule process. So if when you are doing control schedule, if there is any need of again doing what if scenario analysis, you can do that. Or for any new task, you can do that. And if schedule is changed or anything happens, you have to always actually focus on your critical path. Please remember the critical path we have identified in the develop schedule. When you are running the project, that critical path can be changed. All right. It is not true that the schedule that you have defined in the schedule baseline, the critical path, that will be fixed for the whole project, whole schedule. Sometimes for new tasks or for some issues or some risks, so that can actually change. So you have to always focus on critical path, because if critical path is changed, you cannot meet the deadline of the project. All right. So you have to always focus on your critical path. One simple question to ask you, that in a network diagram, is there any chance of having more than one critical path? What do you think? What do you think? Is there any chance of having more than one critical path in a single network diagram?
Yes. Yes.
Yes. Please remember this. Yes, there can be 2, 3, 4 critical paths in a single project, in a single network diagram. So if you are having more critical paths, then what happens? So you are actually very tight situation. That is actually very complex and very tight schedule project, because lot of critical paths and multiple critical paths there. All right.
Does it call near critical path?
No, near critical path is actually, say your critical path is 30 days. All right. There are 3 paths in the network diagram. One is 30 days in duration. Another path, say it is actually 20 days. And another path, for example, that is actually just 29 days.
Yeah.
All right. That means in this path, if one task delayed by 2 days, that actually become the new critical path, will become the new critical path. So this path actually known as near critical path. Okay. All right. Where actually total float will be very less. That path is actually near critical path. That means at any time that path can be critical path. So you have to.
One of the attributes would be there will be very minimal float for in the near critical path.
Okay. Yes. Comparing to the critical path. So as a project manager, only you should not focus on critical path, also you have to focus on near critical paths. Near critical path means the tasks on the near critical paths that you have to also focus on.
Thank you.
Okay, again, you can use resource optimization technique. For example, you have planned to complete the project within 4 months, but at the middle of the project, already 2 months passed, you are seeing that 50% work is not done. Only 20% work is done. So what you need to do? You have to finish this task within 2 months. So maybe you have to again use crushing or fast tracking to finish the work within 2 months. Again, you may need to use leads and lag. All right, leads and lag, right? Negative or positive. So that thing you need to again use, or you need to use schedule compression. Compression, two technique, right? Crushing and fast tracking. So in controlling, based on the situation, you may need to use these tools again. All right. So in Bangladesh or everywhere, what we see, we made a network diagram, then we actually find out the critical path and we take printout of the critical path, that project schedule. And never ever we use or update that critical path or that network diagram or that project schedule. Project actually goes on its own way. We don't follow the project schedule or schedule based line. But as per project management best practices, regularly you have to update the project schedule to understand now where you are now, to understand the variances, the trends, and if need, you have to use resource optimization, leads, lag, schedule compression technique to keep or make your tasks in line so that you can meet the project schedule or deadline.
So we might term them as a traditional way of looking at projects, Bangladeshi context.
Yes, Bangladeshi context. But in Agile, actually, people don't actually hate use Gantt charts or this kind of bar charts. They hate this because actually what happens everywhere, historically everywhere, not in Bangladesh, everywhere actually it is very tough to follow the bar chart or project schedule that we planned early of the project when information is very less in our hand. Maybe we can use in construction project, but those projects are already, we know, we have a lot of experience. But in tangible projects, in knowledge work project, in software project, it is very hard to tell or hard to follow those schedules. That's why in Agile practices, there is no mention of Gantt chart or bar chart or this critical path things.
So how they are going to, meet the deadline then?
They actually follow the iterations, say they have the deadlines, they have to finish this by December. So they actually try to find out, break down the project, like release, and how many iterations they need for each release. That actually, with that, because release duration is already fixed, 2 weeks or 4 weeks. So if you know, we'll need, say, 10 iterations. So you can easily say it will take 10 months because our iteration size is 1 month. So this way they can actually plan for the whole schedule of the project.
It's more or less built in the system, probably. The
Yes.
Agile, more or less built in.
Built in, and everything is transparent, everything is visualized, and every time after every iteration you are seeing something tangible, something usable. So that is actually increases the confidence level of everyone.
Yeah.
But in traditional project, generally what happens at the end, we can see the product.
Yes.
So that is actually very risky. That's why everywhere actually we are trying to mix up the Agile concept with the traditional concepts. All right. So what happens after doing control schedule? At any stage, if we keep updated the schedule, we can actually forecast whether we are going to meet the schedule or not. And also another very important thing is change requests. If any new task happens, or if you see you are lagging behind, or some resources are sick, left the project. So maybe through change request, we have to update the schedule baseline. All right. So these are the main inputs, tools, techniques, and outputs of control schedule. Okay, so one thing we will see that is actually iteration burn down chart in Agile. How actually we perform the progress in Agile, how we check the progress of our project. So they actually use only, most of the project they use only one tool, that is actually iteration burn down chart. So how, if you see, you will get two questions from here. This is a new figure added in PM Worksheet edition. So let me describe this. This is a simple picture. Iteration in iteration burn down chart. What you do? Say this is a 2 weeks iteration, or a 2 weeks iteration, and the team plan that they will deliver 260. For example, 260 story points. Story points in Agile, they actually estimate the user stories using story points based on what is a relative estimation. They said this as relative estimation. So for each story, the whole team actually try to estimate for each story how much story point they need to complete those tasks. Those story, not tasks, story. So for example, this team, they are having 2 weeks of iteration. That means 10 days. And they have decided they will deliver 260 story points in these 10 days, this one iteration. So what they plan see. So 260 is here. So first they actually drew a line at the beginning of the project, beginning of the iteration. 260. So first day, 260 story point are remaining, right? And 10 day, on 10th day, as per the baseline or as per the plan, they will finish all tasks. That means there will be no remaining task. 260, it will be 0 here. All right, it will be 0 here on 10th day. Okay, so this is actually ideal remaining work, the straight line. And actual remaining work, see, when project is progressing, we are on 7th day, for example, on 7th day, what happens? We are actually not within the ideal timeline. We are actually above the timeline. That means if we move like this way, we cannot finish all the 260 story points on 10th day. It will take another, what, 2 days, right? Another 2 days. On 7th day, we are saying we need another 2 days to complete all the story points. All right. So this way we can see how my team is performing, where we are now. So on 7th day, we are still lagging behind. If this way we continue our work, we cannot finish this work within this iteration. We will need another 2 days. So this way actually, and this iteration burn down chart is updated every day when after completing the daily stand-up meeting. So daily stand-up meeting is done in front of the task board. In that task board, this burn down chart is also there. So they see this and they discuss this, and after the meeting, how much they have done. So say first day, say for example, they have completed first day, say 20 story points. So 260 minus 20, that means 240. Their remaining story point is 240. So this is the 240 point. So say for example, on the second day, they have completed another 30. So they are now remaining work is only 210. So this way they actually put the point here. Draw the graph like this. Remaining work. They always calculate remaining work. Okay. So this is actually burn down chart where we are seeing the remaining work in the graph. But there is an opposite graph that is known as iteration burn up chart. Okay. So there actually they will start like this. opposite. That just opposite this. First day, they want to finish 260 tasks, not tasks, story points. So first day, they have completed just 0. Second, one day, maybe they have completed 20. Third day, they have completed another 30, that means 50. So that is actually burned up chart. But they prefer to use actually burned down chart mostly in most of the projects in Agile. All right. But there is also an opposite graph like this that is known as burn up chart. So only this figure is mentioned in PMBOK, but burn down and burned up chart, these terms are mentioned in PMBOK. And in Agile practice guide, you will see both the pictures, both the figures. But in PMBOK, only this picture is explained. And in most of the Agile projects, they only use the burn down chart, not burn up chart. So any question here?
Anyway, what is the, whole purpose of having this chart?
To see the progress of your iteration.
To see the progress.
How much story points remaining.
Okay.
Your day is finishing, but how much your work is still remaining. So progress.
Interchangeably, burn down and burn up chart can be used interchangeably, right?
Right. But why they use actually burn down chart? This is actually a motivational thing. That means when you will see your work is less now in your hand, then you will get more confident, right? So we are seeing that it is finishing. So it is actually creating some mental motivation, right? It is not too far, almost there. We are almost there. Yeah. So that's why actually they use this. Just so mindset.
I have got another question. Like in the first day, have I completed some story points in the day 1, like 260? So at the end of day 1, my story points is 260 or is 240? Is it going to be 240? Day 1 seems to be 260.
260? Day 1 is 260, but day 2, say 240. You have done actually 20 story points first day.
23 points in day 1, right?
Right.
Okay.
So you have to minus 260, minus 20, 240. So this point will be 240. Then in this next day, maybe you have completed 30. So you have to again minus that 30 from this remaining 240. So 210 may be the point. Okay. So always you will subtract. Okay. So this is it. And I think nothing to discuss. So this figure is very important because you will get 1-2 questions, and mostly actually showing this figure, they will say for this figure, if the question comes, whether we are in line with our plan or not. Are we on schedule or we are schedule behind? What will be our answer? Are we on schedule or behind schedule or within we're performing more than our planned schedule? What will be our answer?
Behind.
We are behind, right? So this simple question can come. Yeah. So this is actually mostly used for Agile projects, and they actually use this burn down chart for measuring the progress of their project. So okay, so another day actually passed only on schedule, though I have planned to complete also or at least start and finish 2-3 processes of cost chapter. That was not possible. So I am stopping here for today. So if you have any question, you can ask me. I'm here for another 3-4 minutes.